Okay, so the next problem that we're going to take a look at is finding the area of an irregular shape. So that would be a shape that's not a square or a rectangle. Those are kind of the two that we deal with primarily in third grade. They are usually given a shape that looks like an L, and they have to somehow figure out what the area would be for all of the inside. Now, I've kind of combined two problems into one here to save a little bit of time for you, because if you'll notice here, we're only given 4 of the 6 side lengths for this shape. So built into this problem of finding the area, students are also continuing to practice finding those missing side lengths. So we're going to go ahead and take a look at that. When students get problems like this, I encourage them to do one thing right away. To take 2 different colored pencils or crayons if possible, or to do 2 different lines on all the horizontal and all of the vertical lines. That way they can see that 6 is related to 3 and this other vertical line. And then that 2 is related to 5 and the bottom horizontal line. This kind of just helps them to realize that 2 and 5 and the long one at the bottom are all related. They're all going the same direction. They're all going to have to kind of be in a fact family together. And then the same thing for the vertical lines. So the first thing that we need to do is we need to find the length for, we'll call this Y and Z. We need to figure out what length each of those takes. So first we'll look at the blue vertical lines to figure out Z. We see that 6 runs from the very top to the very bottom, that there's no breaking up. However, 3 goes from top to midway, and then Z is from midway to bottom. A lot of times students will try to say, oh, well, this line goes halfway, so half of 6 is 3. We try to get them away from that because a lot of times it's not halfway. It just looks that way because of the drawing. So when students try and say, oh, it's half, so it has to be this, try and revert them back to their equations and their formulas. So what we would do for this is we see that 6 is the full side length. So 6 is going to be our largest number. 6 would have to equal the same size as the vertical ones across the way. So it would have to be 3 plus Z. They can use their fact families and know that 6 minus 3 would give them the answer of Z. So Z has to equal 3 as well here. So you go ahead and label that one. Then they need to find the missing length for Y. It's the same thing. They see that Y is horizontal on the bottom. It goes from corner to corner, no gaps, no stopping. 5 is a little bit smaller. It stops midway through, and then 2 is smaller as well. So for this one, Y is actually going to be our largest number that's missing for this problem. We know that Y would be the same length as if we put 2 and 5 together. So then we get Y equals 7. Then we go ahead and write those down. So that's kind of the first step that students need to know. They need to know how to use all the familiar sides to figure out who is missing and what that length would be. Now we're going to go ahead and move on to finding the area of the shape. In order to find the area of the shape of an irregular figure, we need to break it up into 2 different regular shapes. Now, there are 2 options with all shapes like this. All students have to do is find a corner that juts in and then either draw it down vertically or draw it across horizontally. I'm actually going to show you both of those ways today. We're just going to have to do them separately. So the first one I'm going to do is I'm going to take this corner here and I'm going to draw the line down vertically. So I now have 2 different shapes. I have a rectangle standing up and I have a rectangle laying down. Again, it helps to have 2 different colors. If not, do a dotted line and a zigzag line. We then have to figure out, I also like to number them, that's 1 and that's 2. We have to figure out the area for each of the shapes. So I know that area equals length times width. For my shape 1, I have a length of 6, so area equals 6 times a width of 2. Again, basic multiplication, area would be 12 units squared. And then you can go ahead and label that as 12 if needed. We then come over and we do the exact same thing for the second shape. Now, what gets tricky is using the right sides. So when I look at this second shape, I realize that it takes all up and down here, which is that whole length of 3. So I'm going to have an area of length times width that uses the number 3. And then many times students will try to use the 7 and do 3 times 7. However, they have to remember that 7 is from corner to corner, and this box does not end at that corner. Rather, it ends at this one in here, which is only that corner to that corner, which has a length of 5. So it would be doing 3 times 5. Area would be 15 units squared. So those would be the two areas for the two different shapes. To find the total, all they have to do is take shape 1 of 15, shape 2 of 12, and add them together for 27 units squared. Now, the other way that the students could do this is using the exact same shape, exact same numbers. I'm going to real quick draw it. 6, 2, 3, 5, 3, and 7. Before, we came down here and did a vertical line. Students could also do a horizontal line and make a smaller one standing up and a longer rectangle lying down. It would be the same process for finding the area of each rectangle and then putting them together. So we're going to do this one first and this one second. Now again, students have to remember that 2 is side to side, so they're good to use that. Area equals 2 times. Now 6 is this corner to this corner, which we do not have since this box started to take it away. So since that part is missing, it cannot be 6. It has to be that length of 3. So it would be 2 times 3, which equals 6 units squared. Then we move on to shape 2. I have corner to corner, no problem, so length of 3. 5 only goes from here to here, that halfway mark, so I cannot use 5. 7, I'm going to take a look. 3 wouldn't make sense because that's up here. A lot of times we cover it up like this so they don't even see it. 6 would not make sense because it's corner to corner. I don't have that. 7, corner to corner, which is what I do have. So I would do 7 times 3, is 21 units squared. Add them together. You still get that same answer of 27 units squared. Now this gets to be tough and time consuming, so I really encourage students to be practicing this daily. It helps on working to find the missing side length as well as what the total area is of an irregular shape. So I hope this helped. Thanks!